Grand Valley State University School of Engineering and Zuidesigns presents the Mobile Application Controlled Mesh Network.
A mesh network is defined as a local network topology where several nodes are connected directly, dynamically, and in no specific order to as many other nodes as possible and cooperate with one another to efficiently route data to and from a central server. This senior design project aimed to create a wireless mesh network of electronic devices controlled by a centralized hub connected to the internet and a mobile application. Each node acts as a receiver and transmitter to send messages along to the next node. The mesh network is proved by using a bank of lockers, where each locker is a node. They communicate with each other and send information down various paths to get the message to the desired node. The phone application communicates with the server, which is wired to the router that acts as the central hub of the mesh network. From the mobile application, users can check out and return a locker, and unlock and lock an owned locker. Administrators to the mesh network can reset the system by removing owners from the lockers and locking and unlocking any locker from the mobile application.
To manage the flow of data between the nodes in the Android application, a server was set up that uses a system called MySQL, which is an open source relational database management system. The data and variables needed for all of the functions of this project were divided into two separate tables titled Nodes and Users. The nodes table handles variables that relate to each node within the system, such as the number of the node, the MAC address belonging to that node, and whether the node is owned or not. The users table handles all of the usernames and passwords that are created from the application, as well as whether that user is an administrator or not, and what node the user owns, if any. The main reason for using MySQL is that it is robust and powerful while also being relatively easy to understand and learn due to its English forward syntax. However, MySQL alone cannot handle the specific commands that need to occur when updating data from the application and the nodes. To handle all of these intricacies, a custom API was written on the server to handle all requests from both the application and the nodes. This API was written in C and allows the application and the nodes to access the server using specific URLs that will trigger different functions based on the query passed to the locker. This allows for the application to keep track of what lockers are owned and unowned, while letting the nodes see which lockers are owned and need to be locked or unlocked. Another function of this API is to see whether a username already exists in that database, which prevents duplicate users from being created or allowing a user to change their password if desired.
Here is the server and the app for the design project. First, we're going to create a new user. Again, new user. And to enter a username, I'll just put my first name. And my password will be GVSU in all caps. And I can create my account. And I can log in using the same username and password I just created. Now on our server side, we'll see that my account has now popped up on the server. So now I'll show you how to do a locker checkout. So all of these lockers are available for checkout. As you can see, 2 and 3 are currently checked out by other users. So we'll use locker number 5 to check out. All right, then I can go to locker configuration, and I have locker 5. I'm now going to lock the locker by clicking this button. So the locker state is actually opposite of this button. So if I click lock, the locker is now locked. If I want to unlock it, I click that again. But I'm going to now lock the locker and save it and return home. If I go back to locker configuration, my locker is still locked. I can also release the locker, which removes me as the owner. I save. I go back to locker configuration. I no longer own locker 5. And we'll see here, there it's available. I'm going to check it out one more time. I'm going to unlock the locker. So now it's unlocked. Save that and return home. To change a username or password, you go to here. So my original username was my first name, Kendra. I'm going to change my username to engineer and save. Now, if I update our server, Kendra has now been replaced with engineer. Same thing goes for password. My current password is capsgbsu. My new password will be student. Save that. And now student. Also, I forgot to mention, since we have locker 5 checked out, it shows up right here as our owned locker. Each of the lockers are nodes, hence why it says owned node. So now I'm going to log out of this account, and I'm going to create an admin account. I can use any username I want again. That's not already taken, of course, in this list. Let's go with Marie, my middle name. And then the password for an admin account is a password that all admin accounts have to share. And if this password is not correct, then you cannot create an admin account. So I'm going to do a fake password, or the incorrect password, which is test. If I try to create an account, alert comes up that is not the admin password. So now I'm going to enter the admin password. And now I was able to create an admin account. It'll pop up right there. Don't share that password with anyone. And then the 2 represents that this is an admin account, where a 1 represented a user account. I'm going to log into this account. So now we're on the admin homepage. So I can go to locker selection. I can select any locker. The X's next to the lockers mean that this locker is currently owned. Previously, with my user account, we checked out locker number 5. So we're going to configure locker number 5, for example, and I'm going to unlock the locker. So I can change the state of the locker from the app. Save that, go back, and go back in, and the locker is currently unlocked. I can also remove the owner from the locker. So when I click that, the owner becomes null. I can save it and go back. And now locker 5 is available. And if I update our server, it shows null for that user account owning locker number 5. Changing the username is the same as it is for any user, but the change password you cannot do because the password has to be special for administrators. And there you are. There is our application for the mesh network concept.
This is the mesh node printed circuit board design. The design is centered around the ESP32 module, which uses the Wi-Fi protocol for transmitting information throughout the mesh network. The circuit board consists of 3 key sections: input power regulation in the upper left quadrant, output power in the upper right quadrant, and the ESP32 interface on the lower half. Power supplied to the board can range from 9 to 36 volts and enters through the 2-pin power connector along the top edge of the board. First, a switching regulator is used to step the input power down to 5 volts. The 5-volt power is then routed to a 5-volt output pin and to a linear voltage regulator. Finally, the linear regulator steps the power down to 3.3 volts needed for powering the ESP32 module. Supplied power is also routed to a relay switch that can be activated and deactivated by the ESP32 module. This allows the supplied power to also become a board output for powering external devices. The design has the ability to sustain up to 10 amps of current, which provides the option for nodes to control power-intensive devices such as motors and solenoids. The lower half of the board provides various connections for interfacing the ESP32 module with external devices. This allows for task versatility between each node in the mesh network. The 6-pin power header on the left edge of the board provides 5-volt and 3.3-volt output pins for powering devices at up to 100 milliamps for each pin. A 0 to 5-volt analog input pin and a 0 to 5-volt digital input pin allow the node to respond to events or feedback driven by connected sensors. The 4-pin program header provides the serial interface used to flash new software to the ESP32 module and observe runtime information through a computer terminal. A 10-pin JTAG interface along the right edge of the board provides a method for testing and debugging the node circuit boards after the manufacturing process. And finally, the two push-button switches on the right side of the board are used for resetting the ESP32 module into either a normal operation mode or into a programming mode for applying new software.
For this project, lockers were renovated. The original locking and unlocking mechanism was replaced with a 3D printed locker mechanism. On the inside of the locker, a 3D printed housing was used to house all of the components of the locking mechanism. A switch was also installed in the inside of the lockers to sense if the locker is open or closed. A solenoid is used to lock and unlock the locker. Inside this housing also contains the PCB. The solenoid pulls down on a lever, which drives up the locker mechanism, unlocking the locker.
In the original design, the solenoid in the locking mechanism was supposed to be a push solenoid. This would allow the solenoid to push the locking mechanism up to unlock the locker and then lock again once power was removed from the solenoid. However, due to supply limitations, there was not enough time to have push solenoids delivered, so the design was altered to utilize a pulling solenoid instead. The system was redesigned to utilize a pivoting arm with a fulcrum in the middle to change the direction of the force put on the locking mechanism. When the solenoid was powered, the pivot arm is pulled towards the solenoid, which in turn raises the other end of the arm that is connected to the locking mechanism. This releases the door from the lock and opens the locker. When power is removed from the solenoid, the pivot arm attached to the solenoid is released, moving the locking mechanism back in place to secure the locker when the door is shut. The downside of this design is the fulcrum could potentially be a point of failure, so care was used when assembling the housings to ensure that the arm did not crack or break. Each locker was outfitted with one of these switch assemblies in the top right of the locker to utilize the digital output of the nodes. In the system, this switch is used to let the users know if the locker is open or closed. When the locker is closed, the door of the locker activates the switch, which can be used in the application to show that the locker is closed. The same holds true for when the door is open. The switch deactivates, letting the application know that the locker is now open. Currently, the project cannot be fully tested in the locker enclosure since the project is still in progress, but the locking mechanism has been tested manually and functions as expected, with each mechanism feeling like a traditional locker when opening and closing the doors.
The primary specifications for this project include each node supporting one relay to pass power from a source, utilizing a single hub to provide a local area network, or LAN, to support the mesh network, having a mobile application request a username and a password in order to access control of a node, allowing the administrator to override user control, and keeping communication time from the Android application to the node and vice versa under 1 second.
There were several challenges faced during this project. First, the ESP mesh contains two analog to digital converters, or ADCs, and unfortunately, one of them conflicts with using the Wi-Fi communication found on the ESP32. The pin we selected uses the conflicting ADC, and therefore, we had to create a breakout circuit in order to get the ADC readings. Moreover, when the boards powered up, they would enter programming mode, where they would wait for the engineer to upload new code instead of running the code currently found on the board. We identified a capacitor that, once removed, corrected the issue. Finally, learning how to use HTTP protocols to send and receive data to and from the server, along with learning how to program the mobile application in JavaScript, proved to be a learning curve that, as a team, we were able to conquer. For future revisions of the project, there are some things that could make the project better and more appealing to users. One of these changes would be to mill the parts out of steel rather than use 3D printed parts. While the 3D printed parts used in this iteration work well, there were instances during assembly of the lockers where parts would break and the team would have to delay the build in order to print a replacement part. With steel parts, this would not have been an issue and would increase the long-term reliability of the locking mechanism. Another improvement to the project that would be nice for the users is to develop an iOS version of the application. Many people own iOS devices and, in the project's current state, would not be able to download the app we developed to use the system. An iOS application would greatly extend the possible user base of this system, but could not be developed in this iteration due to time constraints. The final improvement would be to add a QR code system for the users to scan on the lockers. In theory, this QR code could allow the user to download the application instantly rather than having to search for the app on the Google Play Store. Another use of this QR code would be to allow the user to scan the code and, as long as the user is already logged into the app, check out a locker with little difficulty thanks to the QR code. All of these changes would amount to a more robust and well-rounded system for both the company and users alike. Thank you for watching our video presentation on the mobile application controlled mesh network.